Now, you know Le Chatelier's principle from O levels. There is nothing new here. LCP, Le Chatelier's principle. It simply tells you that whatever, so once you have applied the equilibrium, so Le Chatelier principle only applies when you have two things. You must have equilibrium and you must have a closed system. What this means is that closed system is that surroundings cannot interact with it except for adding or removing energy from it. So surroundings उससे interact नहीं कर सकती, nothing can go out of this system. Sure, you can change the system and get new values, but closed system में वो changes नहीं होंगी. So the Chatellier's principle says that if you change the closed system somehow, so if there is a change, so user applies the change, you apply the change. In response to that, equilibrium counteracts that change. So whatever change you do, equilibrium does the opposite of that. Where have we seen this? In physics? एक बहुत मशहूर law है physics में. Yeah, Newton's third law. Yeah, Newton's third law says that whatever force you apply, there is going to be a counteractive force, so, and which is going to be equal to that, but in opposite direction. Just like that, Le Chatelier principle tells us what the equilibrium does. Whatever you do to it, it tries to counteract that. Obviously, there are practical limitations to कि कितना वो उसको कर सकता है, but it tries to do that as much as it can. Now, there were 5 things that we saw which can affect the rate of a reaction. So rate always is affected. So there is factors like, so what factors affect rate? Can you tell me what factor affects rate? कोई एक का नाम लो.
Concentration.
Concentration. Reactant or product?
Product. Or any
Either.
active. It's
any of them. Yeah. What else? Pressure. Like there's nothing wrong with answering all of them. You can still do it. There is another one which is catalyst, and there's one, I'm saying temperature, pressure, concentration, catalyst, surface area. Now, one of them only applies for gases, so that is this one. So gases only, and this one only applies to solids only. Okay, so what are the effects on the rate? So if you increase temperature, I'm just going to talk about the increase, and the opposite is true for the other ones. So if you increase the temperature, rate increases. Why? Because of kinetic energy. If you increase concentration, the rate increases. Why? Because of more particles. So more particles. So there is higher rate of reaction because they collide more. You will always need to talk about collision because that's the theory we build all of this on. If you increase pressure of a gas, then the gas molecules or gas particles collide more again. So the rate increases. More collisions again. Catalyst lowers the activation energy, so increases the rate again. क्यों? क्योंकि there is more particles with enough energy to react, so they collide more. And then surface area, if you have higher surface area, if the surface area increases, then the rate also increases because of more collisions, more exposed particles. So more exposed particles. So in all of them, we have to relate the answer to collision. So no matter what happens, it has to deal with effective collisions per unit time. There's always the idea of collisions. They have to be successful per unit time. So for it to be successful, it needs to have enough energy. It needs to have the right energy and the right angle at which right orientation at which it collides. So that is the effect on rate. But equilibrium is slightly different from this. In equilibrium, what happens is that catalyst has no effect on equilibrium. No effect, because it increases the rate of both sides, forward and backward reaction. So equilibrium doesn't change. Surface area is irrelevant because equilibrium cannot clump particles together. उनका जो surface area एक दफा expose हो जाएगा, बस वो ही रहेगा. कम ज्यादा नहीं हो सकता unless you're getting precipitates in which you will obviously cannot affect the equilibrium there. So we're left with 3 things that affect equilibrium. Okay. So here's the thing, whenever you talk about these things in exam, always talk about rate as well as equilibrium. By the way, there's another thing which is synonymous with getting equilibrium towards the right side, which is yield. If the equilibrium goes forward, yield increases. So that is something you have to understand, because yield is all about how many moles of particles or moles of product is made compared to how much you wanted. So that is why the more equilibrium goes forward, more product is made. So yield increases. Okay, the rest of this is self-explanatory. If you increase the temperature, equilibrium goes towards the side that is endothermic, because what are you doing? When you increase temperature, you're giving it more kinetic energy. So it will try to absorb that extra kinetic energy. Only then will it be able to go back to an equilibrium state. Okay, so that is why you are going to use the temperature, and it will affect Kc as well, because Kc or Kp, both of them are unique for every temperature condition that you can get. So with temperature, the rates change, the forward and backward thing changes, but differently. Like position of equilibrium will change if you change the temperature. LCP tells us that it's going to go in a way that it undoes whatever change you do to it. So let's say I increase the temperature. The position of equilibrium will move in order to reduce that temperature, right? It's the opposite to do. Uh, how do you reduce temperature of anything? You absorb that extra heat that it has. ठीक है, किसी को बुखार होता है तो वी यूज आइस पैक्स और वो सारा कुछ क्यों करते हैं उनसे, ताकि वो उनकी body temperature कम हो. The heat that it's emanating, we try to absorb that extra heat so the body temperature falls down. Just like that, if overhead you have higher temperature, you have higher kinetic energy, equilibrium will try to absorb that extra energy, और उसके लिए उसे उस साइड पे जाना है which absorbs the energy, and that's endothermic side. So endothermic side is the one that absorbs energy. So LCB tells us that the position will move towards, if it's an exothermic reaction, it will move towards the left. So less of the product is made, yield is lower. Okay, because you have an exothermic reaction rather than. So hydrogen and iodine react to make hydrogen iodide. This is a negative delta H reaction. The values I don't remember. So Kc or Kp iska kya banega? Kp is easy to write. So Kp is going to be pressure of hydrogen iodide squared divided by pressure of iodine times pressure of hydrogen. Similarly, Kc is also something like that. Hi is concentration squared divided by I is concentration and H is concentration. Okay, what am I saying? If I increase the temperature, so I've increased the temperature, equilibrium goes backwards, which means less of this is made, more of this is made, more of this. So this is reduced, this increases, right? Now, will I get a different value for Kp? It's the same for this one. This is reduced, this increases this. Imagine I have a Kp which is, मैंने आपको voice note में बताया था. Let's say it is 3/2. Now, if I double both of them, then it becomes 6/4, which is equal to this. But if I do what I multiply with, what factor I use, I will get a different number. मैं इसको decrease करके 2 कर दूं और इसको increase करके 3 कर दूं, तो it's never going to be the same as that one. But if I use the same change on both sides, then Kc remains the same. So Kp and Kc remain the same if same effect happens to both sides. That's not happening here. So obviously this is in line with LCP. Kp will decrease, Kc will decrease. Uski value change ho jayegi. It will have a lower or a smaller numerator and a greater denominator. So Kp मेरे पास change हो जाएगा उसकी वजह से. But अगर मैं catalyst use करता हूँ, तो catalyst forward और backward दोनों को तेज करेगा. Which means कि if I use a catalyst, then my numerator is going to get a higher value. It's going to increase, and this is also going to increase. So if both of them increase, we have seen here, the value doesn't change because they're both increasing by the same factor. Similarly, what if I change the pressure? If I change the pressure, mole fractions for the new one might be different, but the pressure is the same. जिसकी वजह से मेरे पास जो Kp की वैल्यू आएगी, अभी हमने ऊपर भी देखा कि प्रेशर चेंज करने से उसको कोई फर्क नहीं पड़ता, बिकॉज मोल फ्रैक्शन आपकी इक्विलिब्रियम की वही है. ठीक है, so that is something we have to understand, that Kp does not change if you change the pressure, if you change the catalyst, if you change the concentration. Kc does change if you change the concentration, of course. It tries to come back to the original Kc. ठीक है, और आपका एक ही फैक्टर है जिससे Kc की वैल्यू बदलेगी in any closed system, और वो है temperature. Why? Because temperature affects numerator and denominator differently. Okay, so that's a fact we have to work with. Okay, so that's LCP, and that's the effect of that on yield. That's the effect of that on ये सारा जो हमने देख लिया. In general, we can say that what happens if you add the concentration, if you increase the concentration, the system tries to reduce that. So basically, what does it mean to increase the concentration? It means you're adding more particles. So you have added more particles of reactant or product or whatever. So the system tries to absorb this extra amount that you have added. So it's going to go in either direction to use that up. For example, इस example में मैं iodine ज़्यादा add कर दूँ उसके अंदर, तो it's going to use that extra iodine that I've added. तो वो उसको counteract करेगा. Okay, so it's used up. Yeah, so that is LCP. So tell me, at what condition will an exothermic reaction have a greater yield? At what temperature, high or low, will an exothermic reaction have a greater yield? Come on, in an exothermic reaction, if I increase the temperature, it's going to go towards the backward side. So that means to get a bigger yield, I need to make it go forward, which means I need lower temperature. उसका नुकसान क्या है? उसका नुकसान ये है कि हमारे पास yield तो ज़्यादा हो जाएगी, but rate of reaction will be lower. Okay, so here's a quick question. I have a reaction, ethanol बना रहे हैं हम. We have ethene, and I'm adding hydrogen, water to it at high temperature. So this is steam now, and I'm getting C2H5OH. This is gas. This is gas. This is gas. Okay. If I add more ethene, what happens to equilibrium? Yeah, for industrial processes, we would want a higher yield. Okay, so the best conditions, what is the best condition for any industrial process? Like, what do they want? The best scenario is when they have high rate and high yield. That is the best scenario because it means more money. You are saving time, time is money, and you're getting more product which you can sell. So that is, again, it is a very profitable business. But if you change the conditions, both the rate and the equilibrium will change. So we always try to come up with compromise conditions. What's a compromise condition? Where we get high rate, because again, the most important thing is time is money, but reasonable yield. So we don't want maximum yield most of the time. We want it to be reasonable enough that the factory keeps on running. Okay, so but we still want a high rate. So you might remember from O levels that we talked about nitrogen and hydrogen reacting, exothermic reaction giving us a very low yield, relatively low yield at 450 degrees Celsius, 200 atm. Iron oxide catalyst for iron as well. Now, which of these three is good for yield?
Sir, none of them.
None of them. Isn't a high pressure useful?
Sir, because don't they just affect the rate, not the yield? Doesn't concentration only affect yield?
Not really. If you look at this, you have 4 moles of gases on the left side and 2 moles of gas on the right side, like the ratio. So at high pressure, the equilibrium moves forward. It favors the forward direction. So it will produce more ammonia. It will give us a higher yield.
Okay.
Yeah. So as far as pressure is concerned, that's a good thing for us. But it is an exothermic reaction. So 450 degrees Celsius is not a good idea because it will drive the reaction majorly backward. Okay? Because it's a high temperature. What about catalyst? Will adding more catalyst affect the yield?
No, sir.
No, it won't. Yeah. So these are still compromise conditions. Why? Because all 3 of them give us a better rate. 450 degrees Celsius, excellent rate because high temperature, high kinetic energy, more collisions per unit time. High pressure, excellent rate. Getting a greater yield is just a byproduct of that. And iron or iron oxide catalyst, good. It increases the rate, saves us more time. So notice that my priority here is high rate and we are getting reasonable yield. Sometimes we get yields that are really low, like 20%. But at these conditions, we get like, I don't know, 70% or something. So itni buri nahi hai, itni achhi nahi hai, but still it works. Okay. Last thing for this chapter that you have to know is how does Kc get affected with temperature. ठीक है, अब उसमें एक चीज है कि this isn't really required in A levels, तो but I just think it's a good thing to think about Kc कि वो क्या करता है. So here's the temperature. So let's see what happens to Kc if I increase the temperature. So if I increase the temperature, like if I go to the right, Kc कम होता जाएगा. This is the graph for exothermic reaction. So the reaction is exothermic, greater temperature pushes the equilibrium backwards, Kc की value कम होती जाएगी, less product is made. Okay? And if I have an endothermic reaction, then this is how it goes. So it's not linear, लेकिन इसका effect ये आपके ज़हन में होना चाहिए. This graph isn't really required for you to like, वो एग्जाम में आपसे कहेगा नहीं कि बना के दो, लेकिन I personally like to think of this जब भी कोई question आ जाता है कि अच्छा जी बताएं, if we increase the temperature, how does the Kc change? So अगर मुझे graph याद होगा and I'll know, okay, this is an exothermic reaction, equilibrium is going backwards, Kc is falling down, which means, remember, what is Kc? Kc, a rough way to look at that is the ratio of the product compared to the reactant. So if it has a bigger value, like a value of 2, that means it is 2/1. So there is double the product and half the reactant compared to that. But if it has a low value, like abhi humne shuru mein 0.165 calculate ki thi, that means that I have 16.5% product compared to 100% reactant. So बहुत कम मेरे पास yield आ रही है, बहुत कम ratio है product की. That's a low Kc. That is an equilibrium favoring the backward side. Okay. And yeah, that is it. That is the idea of equilibrium. We'll do a few questions now. Any questions before we move on?